In this video I give you a short introduction to the use of the Jupyter Lab server of the university. So if you go to the web page of the course, Applied Economic Analysis, you can see the address here at the top. And you go to the first Python lecture. You see the link to Jupyter Lab. So before you click that link, block this bit of code here and copy it. Now we'll click on the Jupyter Lab. And you're taken to your area on the Jupyter Lab. It may be the case that you first have to certify given your UVT credentials. I've done it already, so it didn't ask me to do this here. Now the first thing we're going to do is to create a new notebook. So here we have notebooks. So I want to have a Python 3 notebook, so I click on this. And then what I do is that I paste what I just copied from the website. So it's a bash command cloning a certain directory. So the thing to do is to press Shift and Enter at the same time. And then the notebook will actually run that cell. And as you can see, it starts to clone this directory, Applied Economics, which contains the notebook that we're going to be using during the course. You can see I make this a bit bigger actually. So you can see this number here. The fact that you see the number 1 means that actually it finished cloning this GitHub repository. And indeed you can see it's here. So if you run this cell again, so again I'm standing in the cell, so the cursor is in this cell, and I press Shift and Enter at the same time. Now it gives me an error because it's trying to clone this directory, but it already exists. Yeah, so that's why it's throwing an error here. So once you've done this, you can actually close this notebook. We don't need it anymore. And we open a new notebook. So there are a number of things you can do here. So one is if you go to this dot here, so the one with the cross, and you right click with your mouse, you can actually rename it. So you can rename it to something a bit nicer than Untitled. So let's call this Introduction. Yeah, so now the notebook is called Introduction, as you can see here, and you can also see here that I have this notebook called Introduction. You can see these green dots here just in front of the notebook. That means that these notebooks are running. And when you're using the Jupyter Lab, it's important not to have too many notebooks running, because at some point you run out of memory. So the way to shut down a notebook is to click here on Shut Down under this tab here. So we go back here. So now you can see that Untitled is no longer running. There is no green dot in front of it. So the first thing we're going to do is to practice a bit of Markdown. So you can see that this cell is labeled code, which we don't want. We want Markdown. So now it's a Markdown cell. So what we can do here is to have a heading, for instance. And I can press Enter. I can do 2 of the hashtags. That means I have a subheading. And I can even have 3 of them, which means I have a subheading. Now, if we press Shift and Enter at the same time, the Markdown is actually it's shown as the way it's going to be. So that looks a bit nicer. If you want to re-edit this cell, you double click on it and you're back here into these things that you can edit. Yeah, and once you're finished, press Shift and Enter at the same time, and you see the marked up version of the Markdown text. So if you're typing for a bit, it's always a good idea to save your work. So click here on this icon to save it. And you can see that was modified just a couple of seconds ago when I pressed this save icon. So one way to switch to a Markdown cell is to actually use this little menu over here. But another way to do it is to When you're not active in the cell, so you don't have the cursor here, if the cursor is there, you can press escape, so it disappears, and you press the letter M for Markdown, and that turns into a Markdown cell as well. Yeah, so you can choose whether you want to use the menu or whether you prefer to use the keyboard. And if this is a code cell, I just press the letter M to turn it into a Markdown cell. So you see that the two brackets here disappear, and I press enter so that I can actually edit this. So what we can do now is we can make a bullet list. Oops, bullet, and I can have another bullet. And if you want to see what it looks like, press Shift and Enter at the same time, and you can see that indeed it has created two bullets. Yes, there are a number of things you can do in Markdown. So perhaps I want to create a link to a website. So then the name of the link is between square brackets, and then between round brackets I give the address of the link. So let's link to university website www.upt.nl, and I close this with another round bracket. Yeah, so you see that the address itself is hidden, but there is still this name of the link, and when I go to it, I can actually click on it, and it will open the Tilburg University website. Yeah, so that's how you can create links in Markdown by using this very simple syntax. Between square brackets, you give the name of the link, and then between parentheses or rounded brackets, you give the address. Now, another important thing here in Markdown is that you can actually use Latex to type math. Yeah, so things that we can type are, so let's first give this a heading, typing math. So Latex is very useful. It's a very simple language to type mathematics. So if you want to type x squared, this is the way you do it. So you use the caret sign to get the superscript. Yeah, you can also type Greek letters like alpha, beta. Yeah, and it will show these as well once you press Shift Enter. There are more complicated things you can do. So for instance, if you want to have a fraction, the Latex command for fraction is this. So here we have a half. Yeah, so it's frac, and then between curly brackets, first numerator and then the denominator. So we can make this a bit more interesting. So we can have square root of bar x. Yeah, so that's then the equation that you get. If you don't want the equation like in line, so here we have some math in line. Yeah, so here is just added into the sentence itself. If you want to have it displayed, you can use two dollar signs, which are the signs in Latex that you're typing math. So I could do a squared plus b squared is equal to c squared. Yeah, and then it will be shown displayed, so sort of centered in this way. Yes, there are lots of Latex tutorials and manuals on the web, so simply Google if you want to know something. Yeah, so for instance, if you want to know how to do an empty set in Latex, then simply Google Latex empty set. Yeah, so let's do that. So what we want to do is Latex empty set. So here we have the list of Latex mathematical symbols. Yeah, so let's make this a bit bigger. Yeah, so it gives you for Greek letters what Latex symbols are for lots of things. And here we have the one for empty set. Yeah, so it's actually empty set. So let's try that. So empty set Yep, and here indeed we have the symbol for empty set. Yeah, so that's the short introduction to Markdown and how you can use this in the Jupyter notebook. Don't forget to save every now and again. So now let's start a bit of programming. So let's say we want to have a variable a, and we set a equal to 10, and then we want to know what is a plus 5. Again, we use Shift Enter, and it tells us that the outcome is 15. Yeah, you can also have longer variable names, like variable, and let's say variable is equal to 20. Now something that's very useful in the Jupyter notebook is now I start typing var, and I can use the tab key, and then it starts looking to how to complete this variable or function. In this case it's a variable called variable, and that's equal to 20. Yeah, so what I'm using here for completion is basically the tab key. Yeah, so you begin typing the name of the function or the variable that you want, and then you press tab, and it will give you the completion itself. So importing libraries can be done as follows. So one of the libraries that we're going to be using a lot is NumPy. So we import NumPy as np, Shift Enter. And now NumPy is available to us. So just to illustrate, so there's this function NumPy arrange, which basically gives you a range starting from 0 up to 10, but not including 10. Yeah, so it's 0, 1, 2, etc. Yeah, so the more general function is, again, so I type np for NumPy, a dot, and then I type the first two letters of a range, and indeed it gives me this as a possible completion. So let's say I want to go from 0 to 10 with steps of 2. Yeah, so I have 0, 2, 4, 6, 8, 10. Yeah, so I specify 12 here. So Python goes from 0 to 12, but not including 12. So the last number that we get is basically 10. So I can specify a list. I call it my list, so that's a variable. And let's say that my list is NumPy arrange. So let's use the thing we did before, from 0 to 10. So what I can do now is there is this function sum in NumPy. So I can sum my list. Again, I'm using the tab key. And the sum of 0, 1, 2, etc. all the way up to 9 is 45. Another way to do exactly the same thing is to first specify my list. And then do dot sum, which is a function, so we need parentheses, so it's actually called a method, but don't worry about that. So I can do the sum, but I can actually also calculate what the mean is, and the mean in this case is 4.5, because we have 10 numbers and the sum was 45. We can also do some statistics. So there are a number of packages with which you can do this. One of the packages that we're going to be using is PyMC3. So I'm going to import PyMC3 as PM. So it gives me a warning. We don't need to worry about that. As long as you don't get an error, things should be fairly fine. So let's say I'm going to have a couple of draws from a normal distribution. Oops, not normal, but normal. Yes, I want to have a normal distribution. And let's say we take the standard normal distribution. So the mean, the first argument is 0, the standard deviation is 1. I want some random draws from this distribution, and let's say I want 10 numbers out of this distribution. So now what we can do is, from this list, we calculate the mean, and we can calculate the standard deviation. Now I'm drawing from a normal distribution with mean 0, but in the particular draw of 10 items that we have, the mean is of course not exactly 0, because there's some randomness around it. And the standard deviation is not exactly 1 either, which we're drawing from. But if we increase the size, and this is very easy to do in programming, let's say the size is going to be 100, and I can recalculate what I had before, you can see now that the mean is getting closer to 0 and the standard deviation is getting closer to 1. So let's do this once more. So I'm drawing 1,000 elements. Yeah, again, we're getting closer to 0. It's slightly negative in this case. We can add a number of zeros here. Yeah, so if you have a very big sample size, of course, the mean is going to converge to 0 and the standard deviation is going to converge to 1. As a final illustration, let's define a function. So I'm going to define my function. Yeah, you can choose whatever name you want. So the Jupyter notebook is quite clever. So once I've defined the function, it will immediately give me the spaces for the next statement within that function, because Python is space-based, as you will learn later on. So let's say I'm interested in the function x squared. So in Python, when you want to do square, it's actually not the caret sign, but it's the 2 stars. So now I have defined my function, so I can evaluate my function. Let's say what's the value of my function when x is equal to 6, and of course that's 36. So I can also plot this, so I'm going to import the plotting library that we're going to be using a lot. So don't worry if you don't understand what I'm typing at the moment, it's just illustrating the Jupyter notebook, not so much teaching you the Python code itself. So we can import this plotting library as PLT. Now I can define a range for my x variable, so let's say that's going to be numpy array, so we're going from -2 all the way up to 2 and including 2 with steps of 0.1. And then I want to plot this range of x, and I want to know what my function is as a function of x for x in the range of x. Yeah, so this is my first simple plot, and here you have it, a parabola. So this is indeed what this function x squared looks like. So now we can make this plot a bit more fancy, so I can say plt x label. So let's say that I want to have an x on the horizontal axis. Yeah, so I have my x here. But of course, actually this x is math, so I want to use Latex, which I can use here as well. Yeah, so now I have a Latex x. So I can say I do the same thing on the y-axis. So I want to have a y on the y-axis. And I can even have a title. So this is the plot of the function x squared. So here I'm typing Latex, not Python. So now I do it like this. Yeah, so you can see that indeed I have a label here on the x-axis, I have a label on the y-axis, and I have a title on top of my function. This is the plot of the function x squared. So one final thing we can do here is we can actually give this a label, so that there will be a legend later on. So let's say that the label here is, this function is x squared. Just to make sure there's a reason for a label, let's also plot another function. Again, this is range x. So let's use from NumPy the function sinus. And here I use list comprehension to define the range of values for my y variable. Here I'm going to do it directly. This doesn't always work, but in this case it will. The label here is going to be sinus x. I need to close the latex, so I have to do it like this. And then I have to tell matplotlib that I want to have a legend. So now you see that, we still have this title, plot of x squared. So we can adjust that because it's not only x squared, but we also now have sinus x. So this is a plot of the function x squared and sinus x. In blue I have x squared, and in orange I have sinus x. Yeah, so this finishes this short introduction into the use of the Jupyter Lab.